All right, welcome. My name is Joe Rosing, and I lead go-to-market strategy for manufacturing solutions at AWS. And today we're going to be talking about reinventing manufacturing operations and the playbook that's been typically used for driving digital transformation with our industrial customers. High-level agenda, we're going to take a look at just assessing the status quo and what we've seen from experience of running digital transformations and where we're seeing some of the pitfalls. And then we'll start looking at some of the changes or some of the what we're seeing being incorporated as a way to drive additional success. So that comes to developing a data-driven operating model, developing a modern data strategy in conjunction with the use cases that are being deployed, accelerating value with solutions, and then finally just wrapping up with a summary on reinventing manufacturing operations. So to get started on the status quo, what we find is in industry right now, whether you call it Industry 4.0, smart manufacturing, smart factory, a number of industrial customers have started on this journey. And this data is a couple of years old. I would say over 3/4 of manufacturers have started on this journey of digital transformation. But we hear oftentimes that we're not seeing the results from an ROI and a financial perspective that we're expecting. And over 40% of respondents to the survey have stated that one of the reasons or one of the main challenges that they're finding are integration issues. And these integration issues are between different point solutions. They're between existing investments that have been made in the source systems, as well as integration issues with the culture and with the different teams that are involved. Now, as manufacturers think about this digital transformation journey, we talk about what does a data-driven enterprise look like and a data-driven operation look like. And this is usually the motivation or kind of the starting point. We get on a whiteboard and we draw out what do we want to see. And the graphic below kind of demonstrates that, right? We see across our manufacturing footprint, we want to have enterprise visibility into key performance indicators like an OEE, overall equipment effectiveness. We might have some specific use cases we're trying to drive at an enterprise level around maintenance and availability of machines, quality analytics, or a supply chain control tower. And then if we dig one level deeper, usually what we're defining as success is getting into how can we put the data to work from an AI/ML perspective in particular and start to implement that into our operating rhythm. We want the data to be accessible globally, so have enterprise visibility to not only the dashboards, but also the machine learning and the analytic capabilities. And then have data really become an organizational asset where we're breaking down those data silos. And again, I'll keep stressing this, it's not only a technology issue, it's a culture issue, right? So it's the data silos in the different systems that exist, but also the data silos in the different teams that claim ownership of that data and how it's shared. So this is the aspiration, but when we talk about that challenge that we said on the earlier slide with the statistics, this is oftentimes what happens as you start to roll into the deployment. You find typically there's one plant that gets claimed as the center of excellence, and that's going to be the pilot facility. And so they have the shiny objects, right? They're doing the predictive maintenance use case. They have a nice OE dashboard. But then you move to the second plant, and that plant isn't calculating OEE. That plant manager has decided we're going to measure everything by utilization. They have a couple different KPIs. The dashboards look different. Then you move to plant 3, and they say, yeah, availability and reliability of our equipment is important, but really quality analytics is what I want to focus on, and that's what the plant manager is driving. So they start to pick a different use case. And then all the other plants in the footprint start to prioritize what's most important to them. And what ends up happening that starts to stall an enterprise level deployment is you don't have good visibility into your return on the investment because it becomes so disparate across all the use cases and facilities and owners from a plant manager perspective, usually to see what that return is. Each use case then also feels like a rebuild because each plant has their own priorities, and so they say, well, hey, we're going to participate in digital transformation, but since we're going to do our own thing, we're going to build it our own way. And now you don't have anything repeatable, and you start to lose that economy of scale that is really valuable from a cloud digital transformation perspective. And then the end result is that enterprise IT/OT divide persists. Right, and that's one of the things that we're trying to get over as part of Industry 4.0 is breaking down that IT/OT silo. If we double click a little bit deeper into what's driving some of those challenges, some of that deployment, I would say first off, the thing that I'm finding is that continuous improvement culture that oftentimes exists in the manufacturing plant is not integrated with the data-driven operating model. So one of the questions I typically ask, and we'll look at this in a little bit when I go into a manufacturing plant, is what is your project hopper for your Six Sigma program or for your Lean program? What are the projects that are going to help you deliver your productivity target this year? How are we overlaying those projects with your digital transformation? How are we making those projects get done faster and with greater return by applying cloud-based technologies to them? We're not integrated in terms of that program and what we're doing from a data standpoint. The second issue is that more data than ever is being generated. And we've heard these stats before from an IoT perspective, but this goes back to that challenge of why it's so difficult to find that repeatable asset to help enable this. Because you go into a different facility and there are different protocols being used, different ages of equipment, and so it becomes a core challenge for how can we solve with a common process, but also meet the unique requirements of each individual site. And then third is everyone wants to do machine learning. It's the buzzword. Machine learning is hard, and especially in manufacturing plants, you need a lot of historical data to do that, and especially get to a predictive point. And I think what we also find is there can be a tiger team that starts to deploy one machine learning use case in that center of excellence plant. But the machine learning and the data science expertise that's required to maintain that model, to scale that model, to improve that model over time just doesn't exist, right? And so we need better solutions to help address that gap. So we're going to start with at least how we think about integrating that continuous improvement program into a data-driven operating model. Because culturally, this is what I'm finding is a key missing first step when we think about that digital transformation playbook. And there are different variations of this type of maturity slide, right? This is just one that I like to use as I work with manufacturers because it really speaks to how we think about the different levels of data analytics and visualizing that data and incorporating that data into our operating rhythm. I would say most manufacturers have done a great job of getting to level one, that localized real-time visibility. We have dashboards that exist. Now, in some cases, those dashboards are on whiteboards or they're on paper and there's some opportunity for digitization there. But oftentimes there's been some effort done with some form of dashboard, be it through a SCADA system or an MES system or other systems that are in place to at least get that localized visibility. But the second step is now getting that visibility enterprise-wide. Is everyone using the same KPI? Is everyone calculating OEE the same way? Is everyone managing their OEE metric the same way or mismanaging it the same way? Do we understand what those assumptions are? So getting to that level of enterprise-wide visibility is a key next step. That also involves adding the contextual data. It's not just an IoT problem of what the real-time data is. You can't do machine learning if you don't have the contextual data of what's going on in the plant. So connecting into the MES system, into the ERP system, into the historians becomes critical, and that's really that second phase. And then the third phase is when you've developed enough historical data that you can truly get to predictive analytics and starting to apply predictive analytics where it's going to give you the most value. And then finally, the fourth area is where you start to drive optimization with that predictive analytics. Now that I know what's going to happen next week, how am I going to optimize my operation? And what am I going to optimize it for? Am I going to optimize for throughput? Am I going to optimize for quality? Am I going to optimize for cost? And it's a balancing act. That's the art of manufacturing, right? Is balancing those different KPIs. So as I said before, most manufacturers I find are at least at level one. And oftentimes what we get asked is, hey, I don't need a dashboard. I already can see this in Ignition. I can already see this in my MES system. So why do I need additional solutioning? What additional value am I really going to get? And so what I like to ask is, yes, let's say that's the status quo, but is that acceptable? And when we think about is it acceptable, how confident are you in the numbers that you see? And how confident are you in those numbers at that enterprise level, right? Again, that everyone's calculating it the same way. How many people does it take to support the status quo? I was at a customer, they show me their great dashboards that they have, and we're already doing predictive analytics. And come to find out, they're doing predictive analytics only 3 months of the year. Those 3 months are from June to August, because that's when they have interns to run it. Once the interns go back to school, they don't have the people to run the reports and do the analytics. So how many people does it take to put those dashboards together and to get the numbers? What's the Pareto of the opportunity to improve? So let's say you have a dashboard for OEE and it's 70%. Great. What's the top driver that you're going to go address to get it to 75%? Is that a data-driven decision or is that based on instinct? Are you seeing that out of the dashboard today? Or who's doing the analytics to get that answer? And then how many people does it take to do a CI project? We might have a Lean Six Sigma culture. We might have Six Sigma black belts in place. But If their process still involves dumping a lot of data into an Excel spreadsheet and doing VLOOKUPs and doing manual analytics, you're not scaling that black belt capability. And that's really going to be the power of implementing machine learning into your operation and your continuous improvement program, is scaling that black belt capability by automating some of those analytics. And then finally, how are you tracking sustained results? So is the dashboard enough to see this is what I'm doing today, but is it also giving that visibility that the results that I'm driving as a result of the improvements are being sustained over time? So let me give you an example then of how we can think about this from a financial perspective. And this is just a simple model, the DuPont model. You may have seen this before, right? But I like to use this as a simple high-level way to talk through the impact that focusing on OEE can have on plant productivity. Because oftentimes we talk about getting this OEE dashboard up, and we do the project for a while, and then we realize, hey, finance is not signing off on any hard savings, right? Finance is telling me that we can't get an ROI on this. So let's look at an example of why it's still important to focus on these solutions and these KPIs and build them into that operating rhythm. So here you just see kind of a map of the planned hours you're running basically 24/7 as an assumption. We're assuming 52% OEE. We've assumed some cost numbers in here to get to a profit of $61,000. This is all just example numbers. But now let's think if we had visibility, one, into that OEE, but we also had visibility of what's needed to improve that OEE by 10 points, let's say, what impact is that going to have on the operation? Well, let's say I had a Pareto and I decided I'm going to improve those 3 different components of my OEE. I increased it by 10 points. As an assumption, my fixed cost may have increased by 5%. I'm still driving a 36% increase in profitability. Now, there's a lot of assumptions here, right? This assumes that every additional unit of output I can go sell, right, in that model. But we have a lot of manufacturers right now that are working out of a backlog. They want every unit they can possibly get because of the staffing and the supply chain issues that we've all experienced over the last 2 years. So, does doing digital transformation and focusing on something like OEE and implementing cloud technologies to improve your OEE as quickly as possible help? It's an immediate impact to the profitability or the financial impact that the plant can have on the business. But again, it's not just that number, it's how do we integrate it into the operating model? So a couple of things that I've seen from manufacturers that have really been successful at sustaining the results of this. One is prioritizing that project hopper. So when you think about, I want to hit a 5% year-over-year productivity number, if I think about how do I want to increase that OEE by 10 points, what is the project hopper? What's the list of projects that's going to get me there? And do I have data to back up my prioritization? How do we validate hard savings? So, the key question with hard savings is if I save $1 million every year, am I saving the same $1 million? Do I know that I'm incrementally taking money out of the operating budget through the projects that I'm working on? And can I now validate that better because I have better visibility into the data of how my plant is running and at what cost? And then getting the supervisors and the line leaders involved. I used to be a plant manager, and as we implemented this, one of the key successes that we had was think about that OEE kind of the math matrix. We did that for each production line. The supervisor owned it for their line. So they could see on a daily basis the impact that they were having on the financials of the plant by what their staffing decisions were, by how they prioritize running rework versus running active production, for example. It helps them get involved at a much deeper level in sustaining the results of the program and sustaining that in terms of an operating rhythm. And then finally, increase confidence in the operating forecast. So if we want to get to that level 4 and have that optimization, really what we want to get to is at the beginning of the month, when I plan financially for how well the plant is going to perform this month, I'm going to build X amount of units at Y cost position, for example. I want to be accurate. I want to have a minimal variance at the end of the month to that forecast. And the more data, the more visibility that I have, and the more I can predict with confidence how much I'm going to produce on a daily, weekly, and monthly basis, the better I can achieve a lower variance on that forecast. Now, that's some of the value of of how to think about digital transformation in the context of that operating rhythm. But what does it really take to now implement the data strategy to put that in place and to put the underlying technology in place? And this is a slide that I think we've seen a number of our analytics and machine learning teams use, but it's particularly important for manufacturers, is that one size fits nothing at all, right? There's no magic bullet data lake that's going to work for every manufacturer. There are so many different data models, there are so many different protocols in manufacturing that you have to address, that we have to have that flexibility. So let's talk through how we address that with our industrial customers. First and foremost, we need to start with that prioritized use case. So, when on that first slide, having that vision in mind with what are the use cases that are going to drive impact for the enterprise is important. What's also important here is you'll notice I'm not just saying a use case of predictive maintenance. That doesn't help me. We need to define the use cases in a way or define the problem statement in a way that it can be solved by data science or solved by machine learning. And the way that we do that is by making it KPI driven. Think back to your Lean Six Sigma training. What's the big why? Once I know the big why, what are my variables? What are my X's? What data do I have for those X's? How am I ingesting that data today? Now I have a path now to work backwards from that, so that when I go implement a use case, I'm not just doing it for the sake of the use case, but I'm doing it to actually drive a result on that big why, on that metric. So once we have our priority use cases, now what becomes key is how do we deploy those across a horizontal platform? And this is important, because where we've seen a lot of the pitfalls take place is, okay, I'm going to go drive an improvement in machine availability, but I deploy that as a vertical point solution. And now when I go want to do my next use case, I got to do that all over again. And so this is a framework that we use called the Industrial Data Platform. And the way to really read this is to start at the top and think, this is where my use cases are. We call it the act layer, because just deploying the use case is not going to give you any value. Right? The value comes by acting on the data or acting on the insights. And so it's not just a matter of getting to that insight, but what's key about this platform is it's bidirectional. So it allows you to then send the insight back into the source system or the system of transaction so that it's back into the workflow of your maintenance technicians, of your operators, of your line leaders. We also then want to leverage the source systems on the bottom as your existing investment. So what do you have in place today from an IoT standpoint, from an operational data, your SCADA system, your MES system, your ERP? Those are all going to be important so we can leverage what's in place today. And then really the role that AWS and our partners play is connecting the dots in the middle, right? So, and the way that I like to walk through this is whatever that use case is, typically we're going to drive some analytic to get to that result. So that's that analyze box. And here we can take advantage of a breadth of different services and solutions that can support whatever your maturity is on that analytics. Everything from a Monitron, where it's an all-in-one system, sensor, gateway, mobile application, doesn't require any data science knowledge, to a lookout for equipment where it requires some data science capability, but we've automated part of the machine learning process, to something like a SageMaker where you're building custom models and you have the capability to do that. So you have that breadth of analytic capability to go fire up some of those use cases. But those analytics capabilities need the data in a common place, a common data repository. So that's the store layer. And this is where we cover everything from how do you secure and do access management on that data to how do you build the data catalog and build the pipelines coming in. And then collect. We got to get the data into the storage layer. So it's a breadth of IoT capabilities or bringing the data in from those different contextual systems, as well as then what you see in purple of the edge layer, which is very important in manufacturing. We'll talk to this in a couple slides. But it's when we're in manufacturing plants, it is a hybrid model. It's a hybrid on-prem cloud model, and that edge piece is important to meet your requirements for latency and security based on the different use cases. And so having a breadth of capabilities there to deploy or to deploy on or leverage the edge is important. Now, once we start thinking about how we work backwards from those use cases into building this platform at a horizontal level, we also need to think intentionally about what does the modern data strategy look like? How am I going to leverage, as I start to build that cloud layer in the middle, how am I going to leverage those purpose-built databases that are going to serve me based on the different types of data that I'm bringing in so that I can efficiently build this data platform and scale it across the enterprise? Now, while this slide is very, I'll say, database-centric, more IT-centric, what I also like to think about in the context of the modern data strategy is how we do this from a manufacturing standpoint. Most manufacturers are familiar with the ISO 95 model from an infrastructure standpoint of this pyramid, right? Where we have the field data on the bottom, you then have your control layer, your SCADA, your MES, PLM, ERP system as you go up. But that orange line denotes the IT-OT border that exists, right? And the problem with this pyramid is that it's inherently creating data silos across those different horizontal pieces because you have the different standalone applications. And so as a first step, what we see as we work with manufacturers is what of those IT workloads can we move to the cloud to give us greater flexibility and total cost of ownership of those workloads, like an ERP or a PLM. In this case, MES probably should be right on that orange line, as well as starting to get better connectivity on the shop floor level in those OT systems. So starting to understand what is going to be our translation approach, how are we going to handle the different protocols that are involved, and start to get the machines to be talking to each other. But then finally, when we talk about smart factory, what we're really getting to is the IT-OT border being gone and any-to-any communication. So it's one thing to talk about that modern data strategy in the sense of like the previous slide of looking at the different databases and purpose-built capabilities. But when we think about what does that mean for the manufacturing floor, it's connecting it with that IoT edge layer so that you can have that any-to-any communication between what's happening in real time off the machines and what's happening contextually in the different contextual systems. And from there, using that to fire the use cases. And the reason I call out applications on the far right side in particular is because the other thing that's defining smart factory increasingly is the ability to do low-code application building so that you have the ability to create that interface that's going to work for the particular production line for your particular plant. But again, the process of how you get there is common or is the same across all the different plants in the footprint. Now, finally, when we think tactically, okay, now how are we going to go do this? We have these different use cases in mind. How can we get this going quickly? This is where we accelerate value with different solutions. And these can be AWS solutions and/or partner solutions. And so today we're going to walk through a couple of these examples of how we can use solution accelerators as a way to kind of to jumpstart and start moving faster. And so we'll walk through some examples of looking at getting started with that data lake formation, as well as looking at improving equipment and asset availability, improving productivity and quality or your quality yield. Another interesting use case that's been popular over the last year or two is worker safety. So we'll look at how machine learning has been incorporated in a solution for worker safety. And then finally, an example that comes actually out of one of our own Amazon fulfillment centers with the Amazon virtual and-on and digitizing an and-on process. So let's first look at forming that data lake. Now this traditional approach kind of speaks to a bit of what we talked about and just earlier and the work that's involved in forming the data lake, right? When you think about setting up the storage, moving the data, cleansing that data, getting the normalization, the contextualization done so that it makes sense and then you can start to do something with it. And where are you making that data then, that contextual data available for analytics to be driven? This is a long process. And it can get very complicated, especially in a manufacturing environment. And so there are a number of different services and solutions that AWS has along with our partners to help make this run faster. One of those is the lake formation stack that has a number of different capabilities and tools to help stand up for example, the access controls much faster and your data governance much faster. We also have partners that take advantage of this as a way to put an overlay on how they can help support building that industrial data platform, but integrated into your control system and into your other systems. So for example, we do a lot of work with Siemens. If you think about the Siemens industrial edge capability, their MindSphere capability, the Mendix capability, that's an overlay that leverages a lot of these AWS services and in many ways makes it easier to implement for manufacturers because it's simplifying kind of the 200 plus services that are under the hood, so to speak, and making it easier to maintain those. Another example of one of the service capabilities is using AWS Glue. There we go. The key part of Glue in terms of that storage layer is forming the data catalog. So having centralized metadata management, starting to get to the point where you can automate schema discovery. This is going to help in particular as you move from that center of excellence plant onto the other plants within the footprint and start to create common process for how you're managing and handling those data pipelines. The other example too is one that came out I think about a year and a half ago is Glue DataBrew. One of the problems in manufacturing is transforming the data into a contextualized, normalized format that we can start to use it for analytics. What DataBrew allows you to do is to quickly build recipes for those data transformations. And so you can see an example in the box of some of the number of different transformations that can take place that you can stack together in the form of a recipe, all with this user interface that makes it much easier for like a process engineer or an analytics person to start to engage with versus having to do that manually. This is one of those steps too that I think of those interns, right? When they dump all that data into Excel, the amount of VLOOKUPs, the amount of manual formulas that they're running in Excel to get the data transformed, that's a big chunk of the time, right? What DataBrew is doing is automating a lot of that, or building those recipes, so once you do it once, you can repeat it at scale going forward. Now we'll start to look at a couple of the use cases. So the first one I pulled up here is integrated quality management. And the reason that I don't just talk about, for example, a predictive quality model here is, again, it goes back to building these use cases on top of the industrial data platform is key. So if I start with my KPIs, I want to improve the quality yield, I need to understand what variables are impacting my quality yield and how am I collecting that data today. So it might be coming directly off of the equipment, but there might also be relevant data that's being stored in the historian, that contextual data that's in the MES system. I might be visualizing some of that on the shop floor today, but how do I get that all into the data lake? Once it's in the data lake, what also becomes important is how am I integrated into my quality management system as well as my ERP system? Because oftentimes that's where I'm actually doing my quality work. When I think about how am I tracking my defects, how am I doing my 8D reporting, for example, that's happening in those systems. So they need to be relevant in our picture. But then when we think about how are we going to apply machine learning, that's where something like an Amazon Lookout for Vision or doing a custom model in SageMaker can start to now leverage the data in the data lake. But again, you see these arrows as bidirectional, because once I get the insight off of that machine learning model, I want to send it back into the QMS. I don't want another system out there that's just giving me insights that I now have to have somebody manage, right? I've already trained my operators to use my QMS system or use my MES as the way that I'm tracking defects or whichever the process may be. And so what becomes core is when we implement this new capability, we want to integrate the insight back into that workflow to reduce the burden of change management on the shop floor and for our operators. So one of those examples, let's dig into a little bit deeper, is Lookout for Vision as an auto machine learning capability. And really where I look at opportunities in a plant for something like Lookout for Vision is when you walk through and you look at any manual inspection process. Because any manual inspection process that's happening today is limiting throughput. It's also non-value add labor in our operation, right? The customer is not paying for somebody to be there and manually look at a product. And so how can we start to automate this as well as reduce the risk of variation that is inherent when you have a person looking at something and looking for a defect? The other opportunity is where you have automated inspection, but it's at the end of the line. That automated inspection is far away from the point of defect occurring. So how can I move the inspection closer to that point of defect in a way that is low cost and able to scale? So those are kind of the opportunities that I look for in the manufacturing plant when I think about where can I apply Lookout for Vision. Now, what is Lookout for Vision? What Lookout for Vision allows you to do is use existing cameras or low resolution cameras that are lower cost and can be placed closer to that point of defect and start to very quickly train a machine learning model to detect those defects. And in this case, you can see you can do it in as few as 30 images. Now, the images shown in this example with the printed circuit board are very clear, right? If you're looking for bent leads, it's easy to detect those bent leads. And so having 30 images to show what bad looks like is sufficient. The more complex your defect is or the harder it is to see, the more images you're going to have to show or potentially the higher resolution the camera is that you're going to need. But what's great about Lookout for Vision is it is an auto ML service. And so you upload these images into the data lake, into an S3 bucket, for example. And the service is going to start training the model automatically to detect what bad looks like. And you can see there's the user interface here for you to start that training process very simply by clicking a button to say, this is good or bad, right? This is an anomaly, I'm going to claim it as bad. I've now started to train that model for what bad looks like. You have the same interface then on the other side. When the model says this is a defect, the operator can quickly click a button and say, this is a true failure or a false failure to further provide that feedback into the model and continue to improve the model. And so we have this deployed at a number of manufacturers. One example is at Invista. Invista, similar to the example we were given earlier, was looking at their OEE number and they said, hey, we want to improve OEE. And one of the gating items here is looking at our quality. And so how can we implement Lookout for Vision as a way to automate that detection and improve the inspection time such that I can improve the OEE? And so you can see in the benefits here, once it was deployed, the cycle time of detecting those anomalies went from 60 seconds to 5 seconds, greatly increasing the throughput on the line, and a great example of how Lookout for Vision can be used not only to quickly detect defects and improve the quality yield, but also start improving the cycle time on the line and the performance of the line, getting to an OEE improvement. Now, another example is when we look at maintenance and reliability. I intentionally don't label this slide as predictive maintenance, because predictive maintenance is not the silver bullet answer to maintenance and reliability when we talk about machine learning. What's important here is you have the similar framework of I'm going to be pulling data from a number of different sources, but you'll see there are different capabilities that I've integrated from a machine learning standpoint. In the box that's still in the plant, you see Monitron, or asset condition-based monitoring. And Monitron is shown off to the right then on the slide as an example. The yellow boxes are the sensors and the gateways, and then you can see the mobile application. There are some assets where, given the risk of failure and the cost involved in mitigating that risk, is not worth developing a custom predictive maintenance model. So things like pumps, motors, balance of plant type of assets. Where we're finding a lot of success with manufacturers is a really simple solution like Monitron, where you can quickly detect anomalies through a vibration and temperature inputs, and that's sufficient to improve the reliability of those assets and to give you advance notice of when you might need to have a spare or a replacement ready to go. But the same model works then. I'm going to be pulling that data into the data lake. I want to integrate that then in with my EAM or my CMS system, as well as with the ERP system, and these are bidirectional. Because again, I want to reduce the burden of change management on the shop floor and on my maintenance technicians. I don't want them to interact with another system that's running machine learning to tell me when my machine is going to fail. I just want them to continue to work down their list of maintenance work orders, most of which today are preventive in nature, right? They're based off of a cycle. They're based off of a time. But now I'm augmenting that list of work orders with new work orders that are coming by way of machine learning or coming by way of the analytics, because I can integrate in my machine learning capability into that EAM or CMS. And so the two capabilities that I show here are, one, again, SageMaker as a way to build a custom model, but also Lookout for Equipment, which is one of our industrial AutoML services that automates part of the machine learning process for developing those predictive anomaly detection models. And to give an example or an idea of what that does, when you think about what it takes to build a predictive maintenance model, you can see all these boxes in the workflow. So first, I'm going to need to get that input data aggregated and prepared for the model. And then I go through a number of steps in actually building that model, selecting the algorithm, validating it, and getting to the point where I have an output that I can evaluate and go take action on. Well, what Lookout for Equipment does, it automates everything in the blue box. So you point the service to where you have the data sitting in an S3 bucket in that data lake. And then as an output, you're going to get the anomaly detection insights. And then again, from here, now it becomes important. What do I want to integrate those anomaly detection insights into so that it gets integrated into my maintenance workflow? But it greatly accelerates the process of implementing machine learning into your maintenance and reliability program and starts to build what I refer to as a data-driven maintenance and reliability program. We're augmenting what we're doing from a preventative standpoint with things like Monitron for condition-based monitoring, as well as doing true anomaly detection customized to the inputs you're already getting off the control layer or off of a historian using something like Lookout for Equipment. So where has this been deployed? Koch Ag and Energy Solutions spoke with us at Reinvent in November, and they had looked at how do I address the risk of failure of some of my less critical equipment. So they were looking primarily at pumps and motors, where they really weren't involved in their program today. They were basically run to fail, which is very common. We find actually across all manufacturers, about 60 to 65% of assets at least are run to fail. The problem that a lot of manufacturers are running into with run to fail is when they fail, they find that a replacement can no longer be found in 1 week. A replacement is found in 3 months because of the supply chain delays. And that's in fact one of the results that they found here at Koch. So just a couple of the requirements that they had, they recognized that a lot of the failures, a lot of the risks that they had on these assets could be detected through vibration and or temperature. They wanted to quickly deploy sensors. So they did not want to get involved in deploying a sensor, but then figuring out how do I wire this into the control layer or into a PLC. And they wanted to make it so that once they had success, they could scale quickly. So is it low cost enough? Is it simple enough that I could send hardware out to a plant and a maintenance technician could install it with little help? And so the solution that came together was applying Monotron. And Monotron is, again, the orange boxes you see here. You can buy these off of Amazon.com. You put an adhesive on the back and stick it to the asset. The gateways have a 5-year battery life on them, and they integrate directly into a Monotron mobile application. So you can get started right away with that mobile application. But you can also integrate the data that you're getting off of that gateway into your S3, an S3 bucket or into your data lake. And so what that allows you to do then is what you see on basically the bottom workflow is augment that data with what you're already collecting out of your historian. And if you want to add additional models to it, like using Lookout for Equipment or SageMaker, you can do that and integrate it into your EAMS CMS system. And now you've created a workflow that is augmented and enabled by machine learning to help your operators and your subject matter experts start to deploy much faster and at scale. And so the results here, a couple examples you can see, one of the catches that they had on the mobile screen, and then just specifically what the analytics are when they want to go back and dive a little bit deeper. You can see the asset that they had it deployed on there. And as they've had success, now we're in the process of deploying across 5 additional sites with, we've already deployed at 5 sites with 125 sensors, and now we're in the process of scaling that out to about 2,000 sensors in the next year. And that rate of scale and deployment or acceleration of that deployment is not just happening at Koch. We're also doing that in our Amazon fulfillment centers and a number of other customers as well. Because once we find that success and start to demonstrate the value of what Monotron can bring to the plant, it is so easy to deploy in the plant and get started that in 12 months, you can bring another 2,000 sensors on board. And it doesn't require pulling in a controls engineer to figure out how do I integrate that into my PLC. Now, the other use case that I mentioned that has been increasingly popular is looking at safety. And what I find interesting about safety is, for a lot of the use cases we talk about with Industry 4.0, oftentimes we're talking about key resources and assets in the plant, right? The equipment, the processes that are impacting quality of the product, for example. But a key resource in the plant are our people. And so what role are our people playing in our Industry 4.0 strategy? And when you think about PPE compliance or worker safety, think about how manual that process is today. The buddy system, the different checkpoints that are in place. Are you wearing your safety glasses? Did you have your safety review in the morning production meeting? And then when we think about if I wanted to run analytics on compliance to PPE, how well are we doing at keeping our safety glasses on? How well are we doing at making sure people who are not certified to be in the test cell are actually not in the test cell? We have no data around that. And then there's no process automation. So usually it's up to the EH&S lead or the supervisors to just be manually checking that. They might be doing it on paper, but if they're not tracking it or checking it, you have no record that it happened. And so this is a great opportunity to start to deploy machine learning. And this is an example that comes from one of our partners, BigMate, that has integrated some of our machine learning services into their solution in a couple of different use cases. So they can look at safer operation of vehicles. So when are people too close to a vehicle in motion where they shouldn't be? Safe operation of machinery. One of the examples they have is looking at, in the traditional model, we have painted yellow lines on the production floor to make sure no one leaves those lines for safety reasons. Well, we can still keep those, but how do we know that people are complying with those lines? Now we can see that using computer vision as a way to track it and get visibility into how well our employees are staying out of those danger zones. And then just safer work environments, so making sure that when we can detect a potential risk, we can flag that and raise an alert straight away and do it through computer vision versus, again, relying on the buddy system or relying around people on the shop floor calling that out or spotting it out. All right, and then the last example that I have is looking at a solution that, again, comes out of our Amazon fulfillment centers called Amazon Virtual Andon. So if you think about the traditional Andon process, right, it's a great process. It's served us well, but it's very manual, right? So I'm an operator. I have an issue on the production line. I'm having an issue with the machine. It's just not performing to cycle or the way that I want it to. I need to call somebody for help. So I pull the Andon cord. The stack light turns red. A supervisor or a line leader comes over. Hey, Joe, what's the problem? Well, this machine is just giving me trouble today. I need a maintenance technician over here. Okay, well, let me call the maintenance tech. I wait for the maintenance tech to come over. Hey, what's the problem? Well, again, the machine's not running well today. Something's up. All right, well, let me have a look, right? Takes time to get to that issue resolution and to get to the point of understanding what's happening. And plus, you don't have any data around what's going on, at least straight away at your fingertips, right? It's all that conversation driven. So let's think about how we can apply cloud technologies to accelerate this and to drive improvement. Well, if I have what Amazon Virtual Andon does is if I'm that operator, instead of just hitting a button to make the light turn red, I can use a console or basically a tablet that's been pre-configured with buttons that says machine issue. And I can just hit that machine issue button, and I've now flagged the issue in the system. Also, if I'm running a lookout for equipment model or one of the machine learning models, I can integrate that insight into Virtual Andon. So the operator might not see it, but the model has detected that something's going to be happening, and so it will hit the button for me, basically. I can also now detect it directly to the device with integration into the IoT layer. So I can start to get signals directly off the device or the machine and bring it into Andon. And what Andon does is it then has a console to start to collect these issues, and an engineer is automatically called out to fix the problem. So I can configure the solution to say, if I have an issue with the machine, call out this maintenance technician. If my operator hit the quality button, call out the quality manager to come to the line. I've totally eliminated that process of a line lead coming over and saying, hey, what's the problem? Who do we need to call? I've also totally eliminated the process of the solution person, whether that be the maintenance technician or a quality engineer, come to the line and saying, hey, what's the problem? Because now that person can come to the line and say, hey, I see you flagged an issue on machine number 3, and you're seeing that it's underperforming to cycle. Is there anything else that I need to know? They come to the line informed, ready to work, ready to get the machine up and running. So to give you an example of what this looks like, this is the interface, and it has 2 different screens on it. One is the client screen, where the operator would be sitting there and they can start to flag the issues by hitting those buttons, which are all configurable based on what the common issues might be in the line. So I'm out of boxes in this case, right? Or I have a machine issue, I have a quality issue. You can configure that in the solution. And then the bottom is what's called the observer screen. And this is where, like a supervisor, for example, can keep this screen up and just see, hey, what are all the open issues on the shop floor right now? Who's working them? How long have they been open for? And I can start to run analytics on all of that. But I'm also saving all of this data now. So when I think about how am I going to run my Pareto for what are the top hitters that I want to go address in my continuous improvement program, I have data around that for where I had downtimes. That Andon light might be turning red all day long, and we have no data around it today. So by digitizing that process, I can now start to collect that and use that as a way to drive my Pareto and drive my continuous improvement program. So just a couple slides to wrap up here then. Again, when we think about reinventing manufacturing operations, while we've been learning from the last several years of these deployments, there definitely are some best practices that can help us achieve this end state aspiration that we have of deploying common process and common use cases across our manufacturing footprint. But really what it comes down to is it's really important to not only think about, what is that one point solution that's going to get me started to that first use case, but also think through, with my digital transformation program, how am I going to develop a data-driven operating model? How am I going to really integrate these capabilities into what my supervisors, my line leaders, my continuous improvement teams are doing, such that we can sustain those results and augment what we're doing from that productivity standpoint with what we're doing also from a data strategy, digital transformation. And then developing the modern data strategy. Let's not just deploy one vertical point solution, but let's deploy those prioritized use cases against that horizontal industrial data platform that's going to build the foundation for us to then go scale into the future. And then finally, accelerating value with AWS partners and solutions. So I gave one example of our partner BigMate with one of those solutions. We again also do a lot of work with partners like Siemens that can play at really multiple layers of that stack, be it industrial edge, MindSphere, Mendix, Obviously, they also have integrations into things like Ops Center as the MES or Team Center as the PLM, as well as other industrial partners. We just put the GE Prophecy Historian on AWS Marketplace. It's a cloud-enabled historian. So we're starting to see a lot of our industrial partners really take the next leap, that next step, in allowing or enabling their solutions on AWS to help make this easier to stitch together that industrial data platform and that data strategy for these key workloads. And then I also just want to highlight that it doesn't stop inside the four walls of the plant, right? That industrial data platform, if we think back to the slide of the different use cases on top, there are several of those that are in the four walls of the plant. But manufacturing, the actual plant itself, is just one part of the value chain. And it's important to recognize the value that that horizontal platform can then have in what's to the left and to the right of the plant in that value chain. And so it's not just smart factory, but thinking through how can I leverage these capabilities for smart products and services, integrating our products with IoT capabilities, starting to get visibility of how the product is performing in the field, giving those insights to our customers, and giving those insights back into the plant. What does the quality of this product look like in the field? Giving those insights back to our engineering design teams. Based on the input that we're getting of how customers are using it, how is that going to influence the next generation of products, and how can we bake that into our development process? As well as supply chain management. Sometimes a lot of manufacturers, we end up talking supply chain and manufacturing at the same time, right? But it gets into the more visibility I have to how well the plant's performing, that's going to then further help me have better transparency across the supply chain, and then extend into the transparency I'm driving with my suppliers as well as with my distributors on the other side. And then finally, sustainability is an increasing trend that we hear across the board from manufacturers, probably more so in Europe than anywhere else. But we recognize sustainability not only as a standalone use case of, say, smart buildings or smart plants, because manufacturers are high consumers of energy, but also recognizing sustainability as a secondary metric to a lot of the different use cases that we deploy. So if I'm doing a predictive quality use case, my main KPI is improving quality yield. But if that means I've reduced scrap, I've reduced waste, and I can now impact my plant's sustainability metric. If I'm driving increased reliability of my equipment, reliability is sustainability. I was just at a maintenance conference 3-4 months ago, and one of the reliability leaders at the conference was really stressing that as much as we talk about sustainability, recognize that maintenance and reliability is sustainability in a manufacturing plant. The better your equipment is performing, the more efficiently it's performing, the more efficiently it's consuming energy, and the better use of the energy that you're making. So sustainability is one that we see as an overlay metric into a lot of the different use cases we drive in the plant, as well as, again, a standalone for how we can track and get greater transparency into carbon footprint and how well the plant is performing. And so with that, I want to thank you for your attention, your attendance. This is a breakout session, so I want to make sure that we could leave about 10 minutes or so at the end for any questions. And I can take any questions at this time, but also want to highlight, just the 2 items or 2 QR codes here on the screen as part of the AWS Summit here today and tomorrow. So with that, any questions? Good. Okay, well, again, thank you for your attendance. I'll stay up here up on the front for the next 10 minutes or so if you want to come up and chat or have any one-on-one questions for you. But thank you and enjoy the rest of the show.